Alright, in this video we're going to be solving absolute value equations. Our objective in this video is to write and solve equations involving absolute values. So what that means is you're going to have an equation and your variable is going to be closed in the absolute value symbol. Alright, so this is our vocabulary. This is all the vocabulary we have. For this video, if you look right here, it's absolute value. This is the absolute value symbol here, the two straight bars. And since it's an absolute value equation, our variable is going to be inside the absolute value bars. If you'll remember from your middle school math, absolute value is the distance from 0 on the number line. So anytime you take the absolute value of something, because distance is always a positive number, your answer is going to be always positive. So the absolute value of a positive 4 is 4, and the absolute value of negative 4 is 4. Just like in the example below. If you take the absolute value of negative 5, that means you're 5 units away from 0 on the negative side, and if you take the absolute value of positive 5, you're still 5 units away from 0. So actually, anytime you take the absolute value of a number, you're going to have two solutions, just like in this example here. So if you need to, pause the video and write this information down. Alright, here's our first example. We have the absolute value of the quantity 2x equals 14. Alright, first step when you're solving an absolute value equation or inequality is you want to make sure your absolute value bars are by themselves on one side of the equal sign. And all I have here is my absolute value bars and what's inside. So once my bars, I only have the bars on one side, I take what's inside, which is that 2x, and I make two copies. With the first copy, I bring everything down from the other side exactly like it is. With the second copy, I bring everything down, but I flip the sign on everything that's not inside the absolute value bars. And then in this case, I just have a one-step equation to solve. One step because there's one math operation, 2 times x. I divide it by 2, so x equals 7. That's one of my solutions. And same thing over here. I divide by 2. That's the really great thing about the absolute value equations. You follow the same steps to solve both of your problems. And this time, it's a negative 7. So I have two solutions. And with absolute value, you always have to go back and check and make sure your answers work. So I'm going to go back and substitute in 7 for x, and the absolute value, 2 times 7 is 14. The absolute value of 14 is 14. So that one works. Now I'm going to try my other one. 2 times, and I'm substituting in negative 7 for x. 2 times negative 7 is negative 14, and the absolute value of negative 14 is a positive 14, so that works too. You're always going to get two solutions to your absolute value because you've got two numbers on the number line. I have a positive 14, that's 14 away from 0, and I have a negative 14, that's 14 units away from 0. So there's always two possible answer choices on absolute value. Alright, on to the next example. Alright, first question. I'm solving an absolute value equation. Do I have my bars with nothing else hanging outside of them alone on one side of the equal sign? And yes, I do. All I have is the absolute value of the quantity 2x minus 1. Alright, so what I do is my next step. I take what's inside the bars, make two copies. First time, keep everything outside the same. Second time, flip the sign of everything outside. So now I've got a two-step equation to solve. Multiplication, subtraction. I undo my subtraction first with addition. 5 plus 1 is 6. Then I undo my multiplication with division, and x equals 3 is one of my solutions. Now I'm going to do the same thing on this second problem here. And because I made two copies of what's inside the bars, I actually end up doing the same steps that I did with the other problem. So if you get it right the first time, all you have to do is repeat it. But this time I have a -5. I'm at -5 on the number line, and I'm going to move in the positive direction, so I'm moving one more this way, so that puts me at -4. I divide by 2, and I get x equals -2. All right, now you'll notice last time I got a -7 and +7 of my answer. This time I don't do that on this example. I get two different numbers, and I always need to plug them in and make sure they work. So I'm going to substitute in 3 for x, and I get 6 minus 1, absolute value inside the bars, and then I get the absolute value of 5 is 5, so that one works. Now I'm going to plug it in and see what happens with this one. Absolute value, I substituted -2 for x, minus 1. It's supposed to be absolute value bars. So I get -4 minus 1. So now I'm at -4 on the number line, and I'm moving 1 in the negative direction, and it puts me at -5. So I have the absolute value of -5, which is a +5. So that one works too. So both my solutions work. All right, here's example 3 is very similar to example 2. The setup's exactly the same. The numbers are just different. So I'd like you to try this problem on your own. So pause the video, work it on your own, and restart it when you're done. All right, so here's my solutions. I got x equals 2/3 and x equals -2. Here's my work for getting x equals -2/3. Here's my work for getting x equals 2. And down here at the bottom is where I checked out to see if 2/3 worked, and it did. And here is my work where I checked to see if -2 worked, and it also solved the problem. So let's go on to another example. All right, next example, and look, it's a way more complicated because the first 3 examples, I was saying, first question, are the absolute value bars by themselves, nothing hanging around outside of them on one side of the equal sign, and the answer's always been yes. On this one, the answer is no, because I have a -1 out here, and I have a 3 out here. So I have to get rid of that multiplication of 3 and that subtraction of 1. So I'm going to get rid of my subtraction first with addition. So here's what my problem looks like now. 8 plus 1 is 9. Now I've got to get rid of that multiplication. I cannot distribute there. The easiest thing to do is to get rid of the multiplication with division. And now, here's what my problem looks like. The absolute value of x plus 2 equals 3. All right, now I only have the absolute value bars on one side, so now I can write it twice. Write it 2 times. First time, keep everything outside the same. Oops, erase that because that's on the -3. It's just a plain old 3. And this one right here, second time, make everything outside negative. I couldn't write it twice when I got here because I had that multiplication of 3 and that subtraction of 1. I've got to get rid of that before I can write it twice. Now I just have one-step equations to solve. Subtract 2. So I'm at 3 on the number line. I move 2 in the negative direction. That puts me in 1. And I'm going to subtract 2. I'm at -3 on the number line, and I move 2 more in the negative direction, and that puts me at -5. Now I need to go back and check and make sure that both of these work. So I'm going to substitute it in up here. I'm going to substitute in 1 for x, and remember, use that parentheses when you substitute. And I get 3, whoops, I forgot my minus 1. 1 plus 1, 1 plus 2 is 3. Minus 1, so I get 3 times the absolute value of 3. The absolute value of 3 is 3, so 3 times 3 minus 1, which is 9 minus 1, which is equal to 8. So that one works. So now I have to try the second one. And when you substitute in, you always go back to the original problem that you started with. So I'm going to substitute in negative 5 plus 2, close my absolute value bars, minus 1. So now I get negative 5 plus 2, so I'm at negative 5 on the number line. I move 2 in the positive direction. That puts me at negative 3. And absolute value of negative 3 is a positive 3. And I multiply those, and then I get 9 minus 1 equals 8. So this problem answer works too. So I have two solutions here. X equals 1, x equals negative 5. Alright guys, here's another example. Example 5 is very similar to example 4. We have addition outside the absolute value bars, and we have this 2, which is the coefficient in front. That means multiplication. So see if you can follow what we did in example 4 and solve example 5 on your own. So pause the video, work it out on your own, and then restart it to check your work when you're done. Alright, here's my work. Check yours with mine. If you'll see down here, this is the problem, what it looks like when I get the bars by itself. Here's where I wrote it 2 times. And up here at the top is where I checked each one of my answers. And this is what I came up with. If you have any questions about this, make sure you ask me tomorrow in class. Alright, here's our next example. Alright, what's different about this problem is we have our absolute value bars here, and they're by themselves, just like I said is the first question you ask, but over here we don't have a plain old number. But we still follow the same rules. The rules don't change. The bars are by themselves, nothing's hanging about, so we take what's inside the bars, we write it 2 times. With the first one, we keep everything outside the bars, which is this entire quantity here. We rewrite it exactly like it is. But the second time, we take everything and we flip the sign of everything outside the bars. It's basically like taking -1 and multiplying it by that entire quantity. Now we're going to solve both these problems, and they're just problems with variables on each side. So let's see. I'll get rid of the 3x because I want all my variables on one side. So my 3x's cancel out, and I'm left with 2. 4x minus 3x is 1x. I can only subtract the 3x from the 4x because they both have an x. I cannot do it from the 5 because the 5 does not. I bring the 5 down. Now I have a one-step problem. I have addition. I have to get rid of the addition with subtraction. So now my x is equal to -3. Alright, that's one solution. Now I'm going to get my other solution. So I'll do the same thing. I'll just subtract 3x. I bring down my 2. -4. See, they both have an x. They're like terms. So I write down what makes them the same. What makes them the same, you keep the same. And then you do the math with the numbers in front. -4 minus 3 is -7. Alright, so now, two-step equation to solve. A multiplication, subtraction. I undo my subtraction with addition. 2 plus 5 is 7, and then those cancel out, and I bring down my -7x. So now to solve it, I have to get x by itself, so I have to get rid of the negative 7, so I divide by negative 7. So here, my x equals negative 1. All right, now like on all the other problems, I've got to go back and check my answers. So, but not only do I have to substitute it in for x on the left side, I have to substitute that answer in for x on the right side. So now 3 times negative 3 is negative 9 plus 2. Negative 9 plus 2 is negative 7. And the absolute value of negative 7 is positive 7. Now when I substitute it in on the other side, I get 2 times negative 3 is negative 12. Positive times negative is negative plus 5. And I get a negative 7. Alright, positive 7 does not equal negative 7. So guess what? This solution here, x equals negative 3, it does not work. It is what's called an extraneous solution, E-X-T-R-A. So you have the word extra there. Extraneous is spelled A-N-E-O-U-S. What extraneous is it's an extra solution that when you plug it in, the original problem, and you always substitute in the original problem, when you put it in there, it doesn't work. Now let's see what happens with negative 1. Like before, I've got to go back to the original problem and substitute it in for x on one side of the equal sign, substitute it in for x on the other side. Alright, 3 times negative 1 is negative 3 plus 2. And negative 3 plus 2 is negative 1, so I get a 1. And then over here, on the other side of the equal sign, 4 times negative 1 is negative 4 plus 5. Negative 4 plus 5 is 1. Alright, 1 does equal 1, so that solution works. So I only have one solution, one answer to this problem. It is x equals negative 1. And that's why, especially with absolute value, you always go back and check your answer, because sometimes both of the solutions don't work. They don't solve the problem. Alright, here's the example for you to try. Example 7. It follows along like example 6. The bars are by themselves. So since the bars are by themselves, you take what's inside, write it 2 times. First time, set it equal to the positive of what's on the right side. Second time, set it equal to the opposite. So you're going to change all the signs or multiply through the right side by negative 1. So pause the video now, see if you can do this problem on your own, and once you finish, restart the video and check your work. Alright, so here's this problem solved. When I solved it with the first time, the first answer I got was x equals negative 4, and the second answer I got was x equals negative 1. But when I went back and plugged both of them in, when I plugged in negative 4, I got 22 on one side and 14 on the other. Well, that's not correct, because 22 does not equal 14, so negative 4 is an extraneous solution, an extra solution that I get when I solve the problem, but one that doesn't work when I plug it in. My second solution, x equals negative 1, when I plugged it in for x on both sides of the equal sign, I got 7 equals 7, and that's a true statement, so that works. So I only have one solution, x equals negative 1. If you have any questions about this, make sure you ask me tomorrow. Alright, guess what? That's it. In the end, we're done. That's all there is for absolute value equations.